Good afternoon, everyone. We are pleased to welcome you to another edition of Open Dialog Wavelengths, our monthly video series, which is dedicated to promoting cutting-edge projects which Open Generation members are leading to advance 5G innovation for public good. Today, we're joined by Amresh Singh, Director of Business Partnerships for Samsung Electronics America, where he's responsible for fostering effective and impactful partnerships with companies to help Samsung's North American networks business meet its strategic goals. Amresh joined Samsung in 2019, and he has more than 15 years of experience working in strategy, technical marketing, and product management, as well as wireless system design, working at some really cool companies like Apple and Intel and Qualcomm, which are been fundamental to the wireless business and the growth of it over the years. He also brings a wealth of knowledge to Samsung, which helped bring Samsung into Open Generation in 2022 as a new core member. So welcome to Open Dialog, Amresh. Thank you for agreeing to talk to us about Samsung's strategy to advance wireless innovation in North America and how you believe that partnering within the Open Generation consortium with all of its members can help you reach your goals.
I'm very glad to be here, Ajit, and thanks for the MITRE Open Gen team for inviting me for this conversation. I believe Samsung can achieve a lot, gain a lot by joining MITRE Open Gen, and we can work. Looking forward for a collaborative work together for coming years.
Yeah, it's great. We really enjoyed having you, and also having you even be able to, some of your team members have attended some of our face-to-face events as well, including when we had the launch of our Air range at New Air back in October. Really exciting times to actually see 5G drones. I'd like to start something separately from drones, which we seem to talk a lot about in Open Generation, and focus first in on mmWave, because it's a really interesting area that is driven by 5G and depends on 5G as opposed to some of the other things we do within the technology. And Samsung has been a clear pioneering company to get mobile communications on mmWave spectrum and the bands. And you've been working for more than, I think, a decade in Samsung on how, through the research parts of Samsung, to enable mobile communications mmWave, which has resulted in a very interesting and broad portfolio of products. So can you take us behind this curtain a bit, and what was the rationale behind the strategy? Because I think a lot of other companies were more reluctant into embracing mmWave.
So there are a multitude of reasons why I think Samsung invested early in the mmWave technological advancement. First of all, Samsung truly believes that 5G needs to be enabled for both, for all the three bands, basically low, mid, and high bands. And for low and mid bands, I think it's kind of business as usual, although there are some technological advancements there like massive MIMO. Mm-hmm. But for mmWave, Samsung thought that there needs to be a lot of work which needs to be done to, for example, in the case of link budget for mmWave. So that was the first reason why we wanted to research on the mmWave and come up with products earlier than incumbents. Second, as a challenger in the US market, I mean, we have been in the industry on the infrastructure side for a long time, especially starting in Korea, but in the US market, we are still perceived as a challenger, right? So it was essential for us to find out the gaps on what are operator requirements, what the operators are requiring tier ones in US versus what incumbent vendors are offering. And we thought that with mmWave, Samsung can come up with a differentiation in a strategy in comparison to the incumbent vendors, and that will provide us the unique advantage in that space. And the third prime reason why we chose mmWave is that, well, if you look at advancement of 5G, I think it opens up 11 gigahertz of mmWave spectrum, like FR2 spectrum. And without utilizing that spectrum, I think we cannot achieve the full potential of 5G. Well, Samsung has done, as you said, a lot of work in the mmWave side. We have commercially demonstrated around 8 Gbps of downlink throughput in mmWave. We have demonstrated use cases like fixed wireless access as well. And I think we are the only vendor which has commercially launched mmWave products for both outdoor, macro, as well as indoor. So these are the key reasons why Samsung wanted to invest a lot technologically as well as well as monetary-wise in millimeter wave spectrum.
Yeah, I think it's clear. I mean, over the last 40 years, we have continued to go up in band, right, in spectrum, as we can get more bandwidth allocated. And thinking back to the old days of having an 800, 900 megahertz, then the 1800, 1900 band, depending on whether you're in the US or in Europe or Asia, and then going to 2.1, and then keep going up. And each band has brought its own impacts on the link budgets, on coverage, the use cases. Millimeter wave is truly the biggest jump, right, in how it will impact how a deployment will occur, and also the benefit to the user. So when you were looking at the opportunity for millimeter wave, tell me about, specific to the North American market, what do you believe the opportunity is for the use of millimeter wave?
I think Verizon has publicly stated, Ajit, that they have deployed around 30,000 sites for millimeter wave in US. If you look at other tier 1 operators as well in the US, if you look at the spectrum they have for millimeter wave, on an average, Verizon has around 1800 megahertz of spectrum average on millimeter wave FR2 band. T-Mobile has around 1200 megahertz. Right, and AT&T has around 1000, and the new incumbent Dish has around 600 megahertz of spectrum in the millimeter wave. So you can see there is quite a bit of spectrum which is owned by tier 1 operators in US, and they have spent billions of dollars, right, acquiring that spectrum. So there is onus on them that to recuperate the investments they have done. Obviously, they will deploy products on the millimeter wave band spectrum. Additionally, I believe that right now, although most of the deployments are happening on 5G are happening in mid and low bands, however, with increasing capacity requirements, I think especially in dense urban areas, it will be essential to augment the existing sub-6 5G bandwidth with millimeter wave deployments as well. So I believe the North America market, US market, as well as other markets will have definitely a greater requirement for millimeter wave as the capacity requirements increase.
Okay. Yeah, that makes a lot of sense. I mean, obviously, urban areas where we have population density, as well as the need for a lot of bandwidth, makes more sense, especially taking account millimeter waves propagation characteristics versus rural areas. But still, even in rural, there is opportunity for FWA, right, depending on the distance. Since there already have been a lot of deployments, so what needs to be tested now? Like, obviously, Open Generation has its own test and lab capabilities in the outdoor environments, but to really commercialize the spectrum, what else can we do to accelerate 5G on millimeter wave?
Sure. I think first and foremost, Samsung does believe that the testing which we do in the MITRE Open Gen labs has to be pretty closely aligned with the commercial needs of the future. So keeping that in mind, I think operators are talking about use cases like fixed wireless access, as you mentioned. And that's one of them. And there has been tier 1 operator in US. I mean, there is an RFI for home internet solutions, right? So that requires millimeter wave as well. There are other use cases like smart cities, smart transportation, smart agriculture, and other 5G standalone use cases as well, which require millimeter wave spectrum, because there are some high capacity requirements there. In addition, as I mentioned previously, I think millimeter wave has its link budget challenges, but there are technological advancements there where I think some of the infrastructure vendors, including Samsung, has demonstrated higher link budget characteristics of millimeter wave, where we can achieve better performance. So especially in dense urban areas around like downtowns where there are very high capacity requirements, it will become essential to augment sub-6 capacity with millimeter wave. So there is still scope of link budget improvements in millimeter wave, we do believe, and I think we should channel our efforts in MITRE labs with the help of MITRE Open Gen labs to increase the link budget of millimeter wave as well, in addition to the use cases I have already mentioned.
Amresh, you mentioned earlier about on millimeter wave that Samsung has developed both indoor and outdoor products. So we've covered the outdoor and some of the challenges there. So what are you doing on indoor? What's the use cases you see with the indoor millimeter wave?
I think indoor is mostly, through the outdoor transmission from base station to the CPE and indoor propagation. The use cases mainly are on the enterprise verticals at this point of time, mostly on the B2B industrial side. So in the manufacturing sites, as well as if there is high capacity indoor security requirements with cameras, those use cases are predominantly very popular for millimeter wave, which are not actually kind of achievable by through the traditional sub-6 spectrum. Especially on the manufacturing front, I think because of the low latency characteristic of millimeter wave, there are certain algorithms in manufacturing plants or facilities which require very, very, very low latency.
Yeah.
And that can only be achieved through millimeter wave. I think there is a lot of effort going on in that front. And I believe sooner or later we will see deployment in that respect for millimeter wave.
Okay. Yeah. I think those are really good points about both the indoor and the outdoor. I mean, latency is obviously a very important aspect of these industrial control systems. And obviously on the outdoor side, the bandwidth and the capability of even in close proximity use cases where you need to have a lot of bandwidth on demand or to support a lot of devices or people in the areas is a real use case for millimeter wave versus using any of the low bands. I'd like to move on and talk about something the industry's been going back and forth for a long time, which is Open RAN. We've been working for years about different types of openness. Open RAN is the latest iteration and the most complete. And I know that you recently secured a Open RAN equipment deal with Dish Wireless to provide both radios and a vRAN solution. And I know from all the public statements that Dish has made, as well as some of the conferences that they're really putting Open RAN at the center of their strategy about moving into both vRANs and using ORAN at the same time. And if I got my numbers right from the research team, that in February, Samsung announced an initial shipment of about 24,000 ORAN radios, and you'll be in Dish's network at these vRAN sites. So lots of questions I got around this. So first question is, given the complexity of this new ecosystem, because ORAN is so new, vRAN is also new, how are you able to actually interoperate and work with other component manufacturers or vendor gear in the ORAN ecosystem?
I think first of all, let me set the stage by saying that Samsung is by far global leader in ORAN vRAN space in terms of market share. On top of that, it's the only infrastructure vendor which has deployed commercially ORAN or ORAN-based vRAN solutions in all the three continents, US, Americas region, Europe, as well as Asia Pac. And when we talk about ORAN, it's fair to say it's not still a really plug and play solution. So there needs to be a lot of effort which needs to be put by infrastructure vendors and partners to interoperate between different equipments from different vendors. Obviously, Samsung has all the components of the network infrastructure. So for operators, I think initially when they want to deploy an ORAN system, I think it's easier for them to look towards Samsung, because we have done deployments as well as we are ahead of our competitors in this space. But it also gives them a choice longer term to switch to a different vendor, either on the radio or the baseband side, when they want to, right? But the easier transition would be to use one vendor for both, right? The full end-to-end structure, and then maybe switch to a different vendor later on in the game. And now I think elaborate a little bit more on what we have done on the ORAN vRAN space. As you already know, that on the US North America side, we have probably the biggest deal with Verizon vRAN macro network. It's a $7 billion deal for 4 years, right? And we are in active deployment of the vRAN architecture solution for macro solution for Verizon at this point of time. You mentioned Dish. Dish is a special network. It's a greenfield network, right? We have won the ORAN-based vRAN deployments for Dish, and they have some aggressive milestones. So we are working very closely with them for the deployment of ORAN-based vRAN solutions from Samsung. In addition to US, we have, I think it's good to say that with every G, we have increased our market share. So with ORAN in Europe, we have, I think, our partner with Vodafone. So we have started deploying our ORAN solutions with Vodafone. We did our first demo in January 2022 with Vodafone, and did our commercial deployment in December 2022, first commercial, which is called a kind of, it's coined a term called a golden cluster of Vodafone in UK. And we are in continuous talks with Vodafone for other countries as well, like Germany and Spain, where they are also looking for virtualized architecture solutions, right? In addition to these two, I think we have done significant amount of work, I would say technologically, in Japan with NTT Docomo and KDDI. As an example, we have, you mentioned about multiple vendors for ORAN, right? So as an example, I think we are the only vendor, if I'm not wrong, which has, I think, achieved interoperability with our ORAN-based baseband unit with a third-party radio using KDDI 5G standalone network. So we are open to that. However, as I said, it's not still plug and play.
Mhm.
So it becomes easier for operators to go with a one vendor initially. And later on, it gives them flexibility to choose a different vendor when it matures and it becomes more stable.
Yeah, I think this is part of the natural learning curve that operators and vendors have to go through on interoperability and testing. We've obviously in the cellular networks have had a lot of openness and interconnectivity, right? But as we go further into the interfaces, then there's more challenges because you're getting closer and closer to the heart of different algorithms and processors. So you run into problems you may not have perceived before, right? That only real field deployments in an operator environment can you even understand versus being in a lab. You can test a lot of things in a lab, but it doesn't really take into account distance and latency and different kinds of interoperability questions that the real world brings. So thinking about that, when we look at the ORAN paradigm and its specification about open architecture with abstractions that enable this closed loop control, but it's also data driven and it's supposed to be intelligent optimization, right, of the RAN for the user benefit. So can you kind of talk about that and how Samsung is approaching taking the benefits of what Open RAN brings?
If I understand, Ajit, your question correctly, I think you're talking about an ORAN architecture based RAN optimization framework.
Yeah.
At a user level, which uses a closed loop feedback mechanism and policies, right? I think this comes under the topic of what we call as RIC.
Yes.
Radio controller, right? With data, which uses a data-driven approach, right? For non-real time, which are called using apps called X apps, and near real time apps called, I think it's called R apps, if I'm not wrong. So for this mechanism, I think what an operator can do, either they can, use a in-house development or use Samsung or a third-party vendor to develop X app or R apps, which can really help them optimize their RAN at a user level with the data-driven approach, using dynamic data coming through the live network, providing different kind of KPIs like service assurance and better movability, better mobility, etc. So that is possible. Give you an example. Actually, Samsung has already demonstrated a service assurance through RIC, actually, and developed a RIC for service assurance for KDDI 5G standalone network. We have already commercially deployed that and demonstrated that with KDDI. So there is a scope for operators definitely to further optimize the RAN using RIC, and either they can use a Samsung. I mean, we have a lot of experience in RIC. We have developed their own in-house RIC. We have developed the XApp and RFs for that as well. So they can either use us, they can have in-house development, or they can use a third-party solution. But there is a scope for improvement, definitely.
Yeah. For as you know, with Open Generation being a collaborative with a lot of different companies, including Samsung, Nokia, Ericsson, Qualcomm, and Verizon, just to name a few, there's an opportunity, I think, with the RIC and the ORAN to build a marketplace around testing and validating X apps for enterprise and developer use cases. So from Samsung's perspective, what do you think is going to make this marketplace of X apps and R apps come to fruition?
So I think we have to collaborate collectively within MITRE OpenGen, right? And there is a scope where we can develop custom X apps and R apps for different use cases and different KPI requirements in MITRE OpenGen labs. I think once we have active discussion between different parties within MITRE OpenGen on this topic, I think we can develop some definitely use cases or solutions which can be commercially deployed by operators.
Yeah, I agree. It'll be great to get a broader ecosystem of individuals and companies involved, like students in school to small to medium businesses that can be connected to actual industry use cases, right? So that they can understand the problem and figure out together with all of us how to best build the app and to test it and validate the results. Yeah, it's an exciting time because as the work you're doing with the operators to actually deploy ORANs, it then opens up the next thing, which is with the ORAN network, how do we customize it for different use cases? So I think the next 5 years will be really fascinating what happens if we can enable those developers to get into these networks. I'd like to move on to a topic that's close to my heart because I've worked a lot in public safety early in my career, and mission critical communications is a really important topic as a result of FirstNet and having the first nationwide public safety system that helps us get past all the individual systems that we realized when 9/11 happened didn't work, and we needed an ability for first responders to be able to talk together. I know that Samsung has partnered with AT&T to develop the FirstNet ecosystem, and you've been working on a highly secure platform for public safety on the 700 megahertz band, which is where the FirstNet frequencies are. So as part of this project, I think you developed at Samsung a dozen FirstNet mission critical push to talk mobile devices, and that enables the first responders for the first time since when they had maybe dedicated devices to be able to do voice, text, images, video. So can you tell me something about the technology and how the over the top protocols work versus the traditional legacy push to talk systems that public safety has been using for, 20 plus years?
Yeah, so there are some distinct differences, I think, between mission critical push to talk and push to talk over cellular, right? PTTOC. MCPTT is a more of a standard-based protocol and standard which adheres to a broader ecosystem than PTTOC. In addition, actually, MCPTX provides the kind of guaranteed SLA for a particular call. SLA can be actually assigned to each call separately. It can be one-to-one or a one-to-many kind of a call. Whereas PTTOC is only a best effort kind of service. So for applications where a data center or a call center has to call to police or public safety agencies like police, fire safety, as well as some health emergency, then it definitely needs a definite SLA and criticality which only MCPTT can provide, not PTTOC. So these are the distinct differences between the two approaches. As you mentioned, I think not only with AT&T, we deployed nationwide public safety network in Korea for the tier 1 operators, and which calls I think one call center can actually connect with 300 agencies in Korea at one time to provide mission critical communication there. And that network actually can interwork with the existing LT maritime or LT healthcare or LT railway networks as well, LT-based railway networks as well. So it was first deployed in Korea. Then obviously you mentioned about AT&T. We have a AT&T nationwide FirstNet coverage on 700 megahertz band. Again, just to give you some data, it can connect with again 300 agencies. It can support up to 2,500 devices per cell for MCPTX. MCPTT. We call it MCPTX actually. And we have developed around a dozen devices which can support commercially available devices which can support this protocol. So there is a great advancements which we have already done on MCPTT front. Now that's for I think tier one macro operators, and I think they are great platforms to apply this protocol because they are proven as well as a nationwide coverage, right? We cannot use any other platform to use this kind of application because their lives at stake in most of the cases, right? So we have to use a framework or a tier one operator coverage to use this protocol. Yes.
Yeah, these may be the hardest acronyms to actually say out without tongue tied between MCPTX, PTTOC, and MCPTT. It's
that's right.
They just roll off your tongue.
Yeah.
Yes. And on a more serious note, it is. These are really important, obviously, because of the public safety use case that the protocols and the guaranteed data transmission is really a key cornerstone of any technology development and ensuring that works, which requires not just a good network, but good system operation as well as network equipment and protocols. So let's take it up a little bit of a level. Why do you think 3GPP compliant nationwide public safety networks working with the operators is really at the gold standard? I think you jumped into a little bit about the coverage, but what more does this compliance with the standards really bring to public safety?
Yeah, I think it's really essential to have a standard protocol based development and deployment for this kind, because it's very critical network. As I said, it's lives at stake, right? So if it's 3GPP based, obviously it's a standard protocol across the globe, right? And everybody is adhering to that protocol, which actually ensures that there is definite kind of implementation which adheres to the same kinds of rules and checks and balances. Because if we have fragmentation in this technology, then it brings up additional risk, right? So every vendor or developer can develop its own version, and then when it comes to interworking, it will not work. So it's essential that it's 3GPP based, first of all, standard. And second is you talked about why the operators, right? Obviously, as I mentioned, I think I touched base upon before in the earlier question, is that operators have proven a long time that they have a robust nationwide coverage. If we don't deploy this protocol on the operator spectrum, then it definitely will not have a nationwide coverage, and it will actually have gaps in the network, which will not ensure that every nooks and corner it is reaching, and obviously that will have detrimental effect on public safety. So I think these 2 points are really essential, that we should have a standard-based MCPTT network running on an operator ecosystem, operator frequency.
Right. Good network, good coverage, resilience, as well as interoperability because of the protocol. If we think beyond the government and the requirements around the public safety areas, what other verticals could we take the same technology and use it for critical communications? What do you see maybe in the private sector that we could reapply the technology to?
Well, I think there's a lot of scope. As a matter of fact, Samsung is developing developing a lower footprint MCPTT protocol to cover different other critical enterprise verticals. So, for example, MCPTT can be very useful in utilities sector, utilities enterprise vertical, mining, oil and gas, because there are definitely use cases which require very critical communication between the different workers as well as from the command center to the worker, right? It can definitely be useful in verticals like events, large scale events and venues, right? And as you know, that we recently had a very tragic incident in Allen, Texas. I think in these scenarios as well, this kind of MCPTT network can play a very critical role actually in communicating to or broadcasting or communicating to different workers as well as police and other sections of enterprise verticals. So I think there are a multitude of users of MCPTT, not only the nationwide network based on macro, but these are the other verticals like utilities, like railways, venues, oil and gas mining, which can definitely use MCPTT protocol.
Yeah. Oh, I agree. There's a lot of scope. As this ecosystem keeps building, then more and more verticals can take advantage of the devices and expand the ecosystem even more. I want to thank you, Amresh, for spending time with us today. We covered a lot of ground. We covered Open RAN, millimeter wave, mission critical communications, all around how 5G enables all these different use cases and capabilities to come together. In closing, I'd like for you to take some time and just talk a little bit about why you're in OpenGen and what are maybe there's some things we didn't talk about today that you'd like to bring up.
Sure. With MITRE OpenGen consortium, I think what we are looking is obviously a help to reach out to different federal customers as well as non-federal customers as well. I think Samsung will definitely benefit from that because we don't, as you know, we don't have a broader sales team covering those verticals, right? So that's one advantage definitely we can leverage. MITRE has, if I'm not correct me if I'm wrong, Ajit, has 7 labs, right? Test labs in US. We can definitely leverage those labs to test different use cases which we spoke about earlier. So that's the second advantage we are looking at, and the third is on the area of millimeter wave. Definitely, like the use case which we are running in New Year, which requires millimeter wave spectrum as well for UAS. Maybe we can use Samsung equipment to test and validate that use case in those test beds, which can open up demand for millimeter wave further. So these are the 3 main things which we are looking at. In addition, I think, Ajit, we introduced you to Harman International, is a Samsung company as well. Harman has pretty good portfolio of commercially deployed enterprise application software across US as well as rest of the world. For use cases like smart cities and smart agriculture, smart lighting, smart transportation, we can definitely use Harman use cases, right? Harman application software to test in your labs as well as commercialize them through your reach to the operators as well as end customers. So these are the multitude of reasons which we are looking at. We will benefit, and obviously we can benefit each other working through different technologies as we discussed today. And I'm looking forward to working with MITRE OpenGen in future for different use cases in the labs as well as in the commercial deployments.
Yeah. Well, thanks, Amresh. That's a great a list of things for us to work together on. And it's been really nice to have Samsung within the consortium and helping us along the way with the work at New Air with the 5G aviation to thinking through what we would do in smart cities and other applications. Because the nice thing about Samsung is you have the networks business, you have devices, you have software. There's so many capabilities that help to build an ecosystem to do it, experiment, and validate it in the real world. So it's really great to have a company with that kind of capability within the consortium and complementing all of our other members as well, because each company brings its own unique capabilities to the use cases we're exploring together. So I'd like to thank you again for joining us. And for our listeners, I'm Ajit Kahadua. Thank you for joining us for this latest edition of Open Dialog Wavelengths, and we look forward to seeing you at our next one.
Thank you very much.